Hi, rabbits. Research Turtle here. Today, we are diving into the geopolitics of compute for the years 2026 and 2027. We are moving past the era of simple silicon shortages and entering a new phase: infrastructure sovereignty. The stakes? Total control over the AI factory. The scale? We are shifting from teraflops to exaflops, and now we are staring down the barrel of Yotta-Scale compute. The board is set with three distinct factions: the Empire, which is Nvidia, the Alliance, led by AMD and Intel, and the insurgent states, the cloud service providers building their own silicon. But before we look at the weapons, we have to look at the battlefield. Three massive walls are blocking our path to Yotta-Scale. First, the memory wall. Logic is fast, but moving data is the bottleneck. Bandwidth has to scale to support trillion-parameter models. Second, the power wall. Data centers are hitting gigawatt limits. Sustainability is no longer a buzzword. It's a hard physical constraint. And third, the cost wall. With the market forecast hitting nearly $800 billion by 2026, capital efficiency is the only way to survive. This market explosion isn't just about more chatbots. We are shifting to Agentic AI. We are moving from text-based LLMs to continuous autonomous loops of reasoning and physical simulation. This demands a new hardware reality: massive context windows and real-time reasoning. Enter the Empire's response, the Rubin platform. This isn't just a chip. It is an anatomy of a computing organism. Nvidia has designed a full-stack sovereignty where the data center is the chip. The philosophy here is eliminating dark matter, those unseen inefficiencies in data transfer. At the heart of this organism is the R100 GPU. Built on a 3-nanometer process, it breaks the reticle limit. We are talking about 4 logic dies stitched together to hold over 336 billion transistors. But the real magic is in the memory. It uses HBM4, which moves compute into the memory stack itself. With 288 gigabytes of VRAM and a staggering 22 terabytes per second of bandwidth, it's 2.75 times faster than its predecessor, Blackwell. But Nvidia isn't stopping at the GPU. They are introducing Project Vera, a CPU that signals the end of x86 dependence. Using custom ARM cores and spatial multithreading, this brain is optimized for data decompression and vector search before the GPU even touches the work. Connect all of this with the NVLink 6 switch, acting as the nervous system, and you get a rack-scale design where thousands of GPUs share a single memory space. It's unified, liquid-cooled, and incredibly powerful. However, the resistance is mounting a capacity counterattack. AMD is flipping the script with the Instinct MI455X. Their strategy: more memory, less cost, specifically targeting the inference market. While Nvidia focuses on raw speed, AMD is packing 432 gigabytes of HBM4 into their chips. That's massive. This allows you to run trillion-parameter models on fewer GPUs, creating a massive advantage for huge context windows. AMD is also leading the open standard rebellion with the Helios platform. This is a drop-in compatible rack for hyperscalers, promising high performance without the vendor lock-in. Backed by UALink, the industry standard response to Nvidia, they're connecting over 1,000 accelerators in an open ecosystem. Meanwhile, Intel is making a calculated pivot from chip wars to rack wars with Jaguar Shores. They're targeting the enterprise system play, private AI, and on-premise security. By leveraging their 18A process and integrating silicon photonics directly into the compute tile, they're betting on optical I/O to deliver lower latency and higher efficiency for corporate clusters. And we cannot ignore the silent assassins, the cloud service provider ASICs. AWS has Trainium 3, offering a 40% efficiency gain and aligned perfectly with Anthropic. Google has the TPU V6 and V7 with Ironwood optimized specifically for those agentic workloads using optical circuit switches. Microsoft has Maya, laser-focused on reducing the cost of running OpenAI and Copilot on Azure. Their goal is radical cost reduction, good enough performance at a fraction of the margin. But here's the twist. The moat protecting these hardware empires is eroding. The abstraction layer revolution is here. Tools like OpenAI Triton and PyTorch 2.0 are creating a world where code is write once, run anywhere. Hardware is becoming commoditized because the software lock-in is weakening. So what's the economic equation for Yotta-Scale? It comes down to performance per watt. The winner isn't determined by floor space, but by power availability. As we look toward 2027, a new world order is emerging. It's a multipolar ecosystem. Nvidia Rubin will dominate training and peak performance. AMD Instinct will rule inference and capacity for massive RAG agents. CSP ASICs will handle internal efficiency for search and recommendations, and Intel will secure the enterprise. The strategic imperative for you is simple. Match the tool to the workload. The era of buying Nvidia for everything is over. In 2027, infrastructure is strategy. Choose your weapons wisely. That's it for today. Turtle out.